Hey everyone! Welcome to AI Online course. We're diving into an exciting computer vision project, real-time license plate detection, using YOLOv8 and OCR. Whether you're working on parking systems, traffic monitoring, security cameras, or smart city solutions, this project can be a total game changer. Let's first understand what this project is all about. This system detects vehicle number plates from a live video or webcam, and then reads the text on the plates using OCR. It's super useful for real-world applications like surveillance, traffic management, and more. We'll go step by step. Step 1. Collect data for training. Then Step 2. Train the model with YOLOv8. On the other hand, Step 3. Real-time license plate detecting. And finally, extract text using OCR. Let's break it down into 7 simple steps. Step 1. Select dataset. Choose a public dataset for license plate detection from RoboFlow. Step 2. Configure YAML. Modify the YAML file to specify paths and parameters for training. Step 3. Train model. Use YOLOv8 to train the model with the configured dataset. Step 4. Obtain best model. Extract the best performing model weights saved as best.pt. Step 5. Detect plates. Use the best.pt model to detect license plates in images or video. Step 6. Perform OCR. Apply OCR to the detected license plate regions to extract text. Step 7. Detect plates. Show the detection results and recognize license plate text. Before we start with the code, head over to Google and search for real-time license plate detection, AIOnlineCourse.com. You'll find this project on AI Online Course, where they've provided a detailed and well-structured explanation, along with the full code for a deeper dive. Now let's dive into the code. I'll explain each part step by step. First, we import and mount Google Drive to access our files. This connects our Collab notebook to our Drive storage. Next, we install the RoboFlow library, which enables us to seamlessly download the dataset for license plate detection. Then, we utilize RoboFlow to access our license plate dataset by connecting to the project with an API key, selecting the appropriate workspace, project, and version, and downloading it in YOLOv8 format for training. We import OS to handle file paths, set the working directory to license in Google Drive, and confirm the change with os.getcode. We install the ultralytics library, which includes YOLOv8, using pip install ultralytics. Then, we import it and run ultralytics.checks to verify that the library is set up correctly. Here, we train our YOLOv8 model using a pre-trained YOLOv8n.pt model. We specify the dataset with data.yaml, set the training to run for 2 epochs, and use an image size of 640 pixels. We import essential libraries like Torch, OpenCV, Ultralytics, and Matplotlib, along with tools for image processing and visualization to load our model, handle images, and display the detection results. We load our pre-trained YOLOv8 model, best.pt, from the license folder in Google Drive, which we'll use to detect license plates in our images or video. We run inference on an image named car.png using our YOLOv8 model, saving the results with detected license plates for further processing. We loop through the detection results, plot the predictions with bounding boxes, convert the image to RGB format, and display it using Matplotlib to show the detected license plates. We install necessary libraries like utils, Easioker Scikit-image, LAP, FilterP, Pandas, OpenPython, NumPy, and SciPy to support tasks such as OCR, image processing, tracking, and data handling in our project. We import the string library and Easioker, then initialize an EasyOCR reader for English text, disabling GPU usage to perform OCR on our license plates. We create 2 dictionaries to fix common OCR errors. One maps letters like O to numbers like 0, and the other maps numbers back to letters. Then, we print them to confirm the mappings. This function saves our detection results to a CSV file. It writes a header with columns like frame number, car ID, and license plate details, then loops through the results to log each car's bounding box, license plate info, and scores. This function checks if the license plate text matches a 7-character format. First 2 and last 3 characters should be letters, while the third and fourth should be numbers, allowing for mapped characters from our dictionaries. This function corrects the license plate text by mapping specific positions. Letters in positions 0, 1, 4, 5, and 6 are adjusted using dict into char, and numbers in positions 2 and 3 are adjusted using dict char to int. This function uses easy OCR to read text from a cropped license plate image. It processes each detection, converts the text to uppercase, removes spaces, checks if it matches the expected format, and if so, formats and returns the text with its confidence score. This function matches a license plate to a car by checking if the plate's bounding box is inside a car's bounding box. If a match is found, it returns the car's details. Otherwise, it returns default values. We import YOLO, NumPy, CV2, and a custom sort tracker, then create an empty results dictionary and initialize the sort tracker to track vehicles across frames. We load 2 YOLO models, Coco model with YOLOv8 n.pt for vehicles, and license plate detector with best.pt for license plates. Then we load the video and list vehicle class IDs like cars and trucks. We loop through the video frames, detect vehicles using the Coco model, and track them with the sort tracker. Then we detect license plates, match them to cars, crop and process the plates, and use OCR to read the text. Finally, we store the results and save them to a CSV file. We import CSV, NumPy, and sippy.interpolate to handle data. The interpolate bounding boxes function fills in missing frames by interpolating car and license plate bounding boxes, ensuring smooth tracking across frames, and prepares the updated data for further use. We load the test.csv file containing detection data, apply the interpolate bounding boxes function to fill in missing frames, and then save the updated data to a new file, testinterpolated.csv, with the specified headers. We import AST, CV2, NumPy, and pandas for data and image processing. The draw border function adds a green border around the car by drawing lines at the corners of the bounding box, making the car detection visually clear. We load testinterpolated.csv with pandas, read the input video, and initialize a video writer with matching frame rate and resolution. We create a dictionary to store each car's license plate info, select the best detection, crop and resize it from the frame, and save it. Then, we reset the video to the first frame. We loop through the video frames, draw a green border around each car and a red box around the license plate, then overlay the cropped plate and its text above the car. We save the edited frames to a new video, resize them, and finally close the video files. This function compresses a video using FFmpeg and returns a base 64, encoded data URL for inline display in IPython. It compresses out 1.mp4, encodes it in base 64, and embeds it as a playable 400px wide HTML5 video in IPython, and the output to show real-time car license plate detection. That's all for today's video. Thank you for watching. If you liked this project, don't forget to hit the like button and subscribe for more tech tutorials. Check out our next video on object detection with YOLOv8, link in the description. See you in the next one.